We are working through question 8. Let's begin by giving it a read. It says the function f is a polynomial function of degree 4, and as you can see, its domain is all real numbers. Part of the graph of f is shown below. The graph of f touches the x-axis at the origin. So the first thing I would want to do is just come down here and just put in that piece of information. I know it's going to touch at the origin right there. Okay, so this is my f of x. The very first thing that I need to do is write down the rule of f. What we're going to do here is consider each x-intercept. So as you can see right here, I have an x-intercept at -1. And what that means is that I know a component of my rule is going to be x plus 1. And I know that because if I was to set x plus 1 equal to 0, I'm going to end up with x equaling -1. And we know that that's true because that's my x-intercept there. Okay, so let's now apply that same logic over to this side right here. This one is obviously going to be x minus 1, because if I was to set that equal to 0, it's going to be x is equal to 1. The final place where it touches the x-axis is at the origin here, and what's important about this one is that it is a repeated root. So let me write that down. The way that you can identify that it's a repeated root is because it bounces, it bounces there. So that means right here, I'm going to end up with x squared. Okay, let's now write down what my rule is going to be. It's going to be f of x is equal to x squared, then x plus 1, and then x minus 1. I would immediately recognize that x plus 1, x minus 1 can be written like so. X squared minus 1, just difference of perfect squares, so I can write it like that. And now this is where most people would leave their answer. And they'd be wrong for several reasons, but one of the reasons why they would be wrong is this is a quartic that has been reflected across my x-axis, so there would actually be a negative there. But that isn't the main reason why people would get this question wrong. And even if you didn't know that, it's not that big of a deal because you can find that out later. The main reason why people got this one wrong is because they didn't realize that you have a dilation factor. You have a dilation factor that you need to consider. You need to find out what the dilation factor is. And the way that you're going to find out what the dilation factor is by subbing in a point. So I'm now going to sub in this point to find what A is going to be. So let me just write that down so you know what we're doing here. We're going to sub in this right here, which is 1 over the square root of 2, 1. And we're doing this in order to find what my dilation factor is, which we are calling A. So let's now do that. Let's zoom in and let's see how we go. So I'm going to say that I have 1 equals, I still have this A here. It's going to be x squared. So that means I'm going to get 1 over the square root of 2 squared. Then I'm going to get 1 over the square root of 2, and that's also going to be squared, minus 1, like that, which means I'm going to get 1 is equal to, this is going to be A. The square root of 1 is 1. The square root of 2, 1 squared is 1. 1 squared is 1. The square root of 2 squared is just going to be 2. So therefore, this 2 is going to be 1 over 2 minus 1, so it's going to be negative 1 over 2. And then we're going to keep on going. And obviously what I'm going to end up with here is 1 is equal to A. This is going to be negative 1 over 4, so let me just write it like this. It's going to be negative 4A, which means therefore A is going to be equal to negative 4. That's what A is going to be equal to. And notice the fact that I said that if you did not know that this was reflected across the x-axis and therefore has a negative in front, we can figure that out later. Well, we just figured it out. Look, negative there. So don't be too freaked out if you didn't know that, because we just figured it out together. All right, so let's now write down what our final answer is going to be. It's going to be f of x is going to be equal to my dilation factor of negative 4, x squared, and then x squared minus 1. Just like that. Let's now highlight that. That's what it's going to be. All right, let's now look at the examiner's report and see how people did with this question. So, as you can see, whoa, this was not well done. 14% of the state got the full 1 mark. Here is our answer right here, negative 4x squared minus 1. This question was well attempted, but not well done. Many students overlooking the dilation factor. So that's what I said over here. You need to remember that dilation factor, which you then solve by subbing in a point. Perfect. Let's now move on to our next one, in which we have this. So what are we doing here? So now we have let g be a function with the same rule as f. Let h be such that h of x is equal to log e of g of x minus log e of x cubed plus x squared, where d is the maximal domain of h, state d. Okay, so we need to find what the maximal domain of this is going to be. We have been told that my g of x, so g, is the same thing as f. So that means the very first thing I would do is simply rewrite it with that piece of information. So I know that h of x is going to be equal to log e, and in place of g of x, I can just put f of x. So it's going to be negative 4x squared, x squared minus 1. Then I'm going to minus log e of x cubed plus x squared. Okay, let's make sure I didn't copy anything down wrong there. It doesn't look like I have. Now, when we're finding what the maximal domain is going to be, what we're going to realize is that I can't log a negative number. So this has to be greater than 0, and this has to be greater than 0. So let's find out when that is true. So I'm going to have negative 4x squared, x squared minus 1 has to be greater than 0. Just greater than 0, not greater than or equal to, just greater than 0. Now, whenever you're trying to find an inequality that is not linear, you have to graph it. You have to graph it. But thankfully, we already have the graph of this, which we found in part A. So that just means we're just going to mosey on back up here and consider where this graph is greater than 0, which means where is it greater than your x-axis? Where is it above the x-axis? So obviously it's above the x-axis here, and here, and here, and here. But remember, we do not include the x-axis because it's not greater than or equal to, it's just greater than. So we're not going to include those points right there. So that means if I could just come down here, and just so we have everything in the same spot, you obviously wouldn't do this in the exam, but let me just show you that you would have to do this. We're going to do, it's going to look like this, just so we have everything in the same spot. So it's not going to include that spot, or that spot. It's going to be up, down, like that, which means my x is going to be 0 to, sorry, this is negative 1, this is 0, this is 1. It's going to be negative 1 to 0, the union of 0 to 1. Be careful of your brackets there, that you don't mess it up. The other way you could write this is you could say we are going from negative 1 to 1, but we are excluding 0, and you have to put 0 in the fancy brackets like so. That is the other way you could say what the domain of this is going to be. We now need to figure out what this one's going to be. So x cubed plus x squared also has to be greater than 0. And remember, the way you do this is by giving it a bit of a sketch. So we're going to do this, we're going to do this. What we're going to do is we're going to take out a common factor of x squared, which is going to leave me with x plus 1 here, which is greater than 0. I can therefore say that I'm going to touch the x-axis here, which is a repeated root, so it's going to bounce there, and that's negative 1 as well. So my graph is going to look something like this. Bounce. Where is this greater than 0, but not touching it, so it's not going to touch. It's not going to include those points. So that. So it's going to be my x is negative 1 to 0, the union of 0 to infinity. Okay, so now we have figured out both of those. We have figured this out, and we have figured this out. what now is my D going to be equal to? So what is my D going to be equal to? So that is the domain of h of x. Now, even though this one goes to infinity, we know that we can't put in, 10 or something greater than 1 into this part, because if we did, we would end up with a negative there and the whole thing would break. So the place where these two domains have in common, where they overlap, would simply be, well, at negative 1, all the way to 1, but you're excluding that 0 right there. So it's just going to be that. And remember, the other way you could write that is using that notation, but I'm just going to leave it there. So that's how you would approach that question right there to figure out what the domain is going to be. All right, let's now look at the examiner's report and see how people did with this. So where did I put it? Put it down here. All right, so as you can see, this is what we did here. We had -1, 1. Good, so make sure you don't mess up the notation. Only 9% of the state got the 1 mark for that. Students who did this question well realized the maximal domain could be obtained by considering the common domains for f of x is greater than 0, observed from the graph given in part A. That's what we did, hooray. And x cubed plus x squared is greater than 0. Some students were not clear on how to express the interval. So as you can see, we did that. We set that greater than 0, we set that greater than 0, and we found where they had common domains. Perfect. As you can see, kind of a tricky question. Only 9% of the state got it. All right. So let's now move on to the final part of this question down here, in which we need to state the range of h. Now, when you're stating the range of anything, what I would want to do is actually draw for myself a graph of it, and then I can see what my range is going to be. So let's just remind ourselves what we will be graphing. We're graphing this right here, this monster. Look at it. It's a monster. All right, so this is what we are graphing. And you might be thinking to yourself, how on earth are we going to graph that? Well, we're going to have to use our log rules to kind of simplify this down before we can do anything, because in its current form, you couldn't graph that by hand. So we have h of x. Now, when I have two logs with the same base subtracting from one another, I know that they're simply going to divide. So that means I'm going to get log of e of -4x squared, x squared minus 1 over x cubed plus x squared. Now, what I want to do now is simplify this as much as possible. So the very first thing I'm going to do is take out, if I have this, let me just use the power of technology a little bit here. Control C, Control V, and computer's great. So what I'm going to do is I'm going to take out a common factor here of x squared. So I'm going to be left with x plus 1, and that means I can get rid of this. And I've got x plus 1 here, and, well, this is difference of perfect squares. I can rewrite this as x plus 1, x minus 1. So the reason why I've done that, hopefully you can see, I can get rid of that and that. All right, so that means what I'm going to be left with here is log e -4 x minus 1. That's what I have. Perfect. All right, let's highlight that. That is my h of x. Now, let's give that a graph. So let me again use the power of technology to do this. Like this. And like that, and let's just make that a bit thicker. All right, and now we're going to give this a graph. So you might like to just remind yourself what a log graph looks like. It looks like this. This negative here means it's going to be reflected across the y-axis, so it's going to look like that. And then, because we have this -1 here, it means it's going to be shifted one to the right. So it's going to look like that. And remember, I have a vertical asymptote at x is equal to 1. That's how it works. So I'm going to have a vertical asymptote here. This graph, we're not being examined on the graph, so it can look as messy as I like. It's just helping us figuring out what the range is going to be. Now, we also have to consider the domain. So let's remind ourselves what the domain of h of x is. What is it again? It is this monster. come down here with me. All right, so we've got this. So that means that it's not going to go on forever. At -1, it's going to stop. And it's also not going to exist at 0, so not going to exist there. So what I need to now find out is what is the coordinates for that and what is the coordinates for that. The way I do that is simply by going, I've got h, I'm going to sub in, let me sub in -1 first. I'm going to sub in -1. Let me see if I can write that a bit better. I'm going to go h -1 is equal to log of e. If I was to put -1 into this, it's going to be -2. -2 times -4 is going to be +8. So that means this point right here is going to be -1 log e of 8. And then I also need to find this point. To do that, I'm going to sub in 0. So I'm going to get log e. If I was to sub 0 into this, I'm just going to be left with -1. -1 times -4 is +4. So that means I'm going to end up with 0 log e of 4, just like that. All right, so now that I have that, I can write down what my range is going to be. So what is my range? Well, what we could say is that my range is... So if we can think for a moment, we're looking at our y values. Obviously, it's going from -infinity, all the way to, we know that this point is where it stops, and that's log e of 8. So it's going to be log e of 8. And we also know it's excluding here. You've got a circle there, an empty circle, so you know it's not going to include it. So we're going to do this, and we're going to say, we're going to remember these fancy little brackets here, log e of 4 is that point right there. All right, that is our answer. Just that right there. So let's now look at the examiner's report and see how people did with this question. So let's come out here. Whoops, I put it right there. That was bad placing. Let's bring this down. All right, so as you can see, what we have here is what my h of x is, log e for 1 minus x, and that's what we found over here. Written just a little bit differently. Our negative is out there, but that's all right. As you can see, that's what we wrote, -infinity log e to the 8, not including log e to the 4. Whoa, 1% of people who did this got the full 2 marks. Not many students attempted this question. Only a few students used logarithm laws, and some students sketched various graphs with limited success. So a tricky question, only 1%. And that's really because it kind of compounded each time. If you didn't get the first question right, you couldn't do the second, you couldn't do the third. So that's why, yeah, it was kind of a tricky question. But there you go. Hopefully that has helped you get through question 8 of this exam. And I'll see you in the next video.